Hi everyone. Today's topic is on foundation. Session 9. Content of this slide: causes for failure of foundation and preventive measures. Hi everyone. Today's topic is on foundation. Session 9. Content. Today we'll be discussing on causes for failure of foundations and its preventive measures. Recap. Before going to the topic, we'll just discuss briefly what we have studied in the last class. Types of foundation. In types of foundation, we have studied why foundation is necessary, what is its major criteria. Foundation is mainly classified into two types. One is shallow foundation, another one is deep foundation. Again, in the shallow foundation, we studied what is meant by shallow foundation. If the depth is less than or equal to its width, then it's called as a shallow foundation. And in shallow foundation, we studied four different types. Fre- It's a spread footing, combined footing, strap footing, and raft footing. Again, the spread footing is divided into three main types, that is wall footing, column footing, and arch footing. Okay, and we'll come to today's topic, that is causes for failure of foundation and its preventive measures. Okay, there are mainly six main causes for failure of foundation. So first one is due to unequal settlement of a subsoil. Second one is unequal settlement of a masonry. Third one is horizontal movement in adjoining soil. Fourth one is moisture withdrawal from subsoil. Fifth one is lateral pressure on the superstructure. Sixth one is action of atmospheric agencies. Okay, why the foundation will fail? What are its major acts on it? So foundation will mainly fail due to some reasons. See, if we don't select a proper soil which has very low bearing capacity, then the foundation will fail. And due to improper compaction, compaction has to be done. Compaction means, layer by layer, the soil has to be compacted in a well manner. So that is called as compaction. Compaction has to be done properly. Again, construction stage, while doing the construction, we have to take utmost care, and proper care has to be taken. Okay, means maintaining proper standards given by the Indian standards, and proper choosing the proper construction materials, cement, sand, etc. Again, due to improper drainage. Drainage means for the removal of wastewater from the house. Okay, that has to be taken care properly. There won't be any leakage, shouldn't be happening there. Again, density of the soil, it matters a lot. How dense the soil is it good for the construction? What type of a soil we are will be underneath our structure? So these are the aspects will decide the foundation strength. Okay, we'll discuss all the six one by one. We'll move on to next slide. Okay, causes for failure of foundation and its preventive measures. The first one is unequal settlement of subsoil. So, if I say subsoil, what is it is the soil which is coming under the structure. So, okay, why this failure happens? It happens due to this following reasons. If we speaking about soil, the soil has to be dense enough, and it should be a good soil. It should be a uniform throughout the foundation in same kind of a soil. If I see ಕ್ಲೇಯಿ ಸಾಯಿಲ್ ಅದಿತ್ತು ಅಂತಂದ್ರೆ ಕ್ಲೇಯಿ ಸಾಯಿಲ್ ಎಲ್ಲಾ ಕಡೆನೂ ಕ್ಲೇಯಿ ಸಾಯಿಲ್ ಇರಬೇಕು. ಅಥವಾ ಇಫ್ ರೆಡ್ ಸಾಯಿಲ್ ಇಟ್ಸ್ ವೆರಿ ಗುಡ್ ಫಾರ್ ಕನ್ಸ್ಟ್ರಕ್ಷನ್. ಸೊ ಆತರ. ಸೊ ನನ್ಗೇನಿರ್ಬೇಕು, ಯೂನಿಫಾರ್ಮ್ ಟೆಕ್ಸ್ಚರ್ ಆಫ್ ಸಾಯಿಲ್ ಇದ್ರೆ ಸೊ ಫೌಂಡೇಶನ್ ಚೆನ್ನಾಗಿರುತ್ತೆ. ಓಕೆ, ಸೊ ನೇಚರ್ ಆಫ್ ಸಾಯಿಲ್ ಆಲ್ಸೋ ಮ್ಯಾಟರ್ಸ್. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಲೋಡ್ಸ್. Okay, load applying of load should be uniform throughout the structure. If unequal ಆಗಿ ನಾನು ಲೋಡ್ ಏನಾದ್ರು ಅಪ್ಲೈ ಮಾಡಿದೆ, ಇಫ್ ಎ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಒಂಥರ ಬಿ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಒಂಥರ ಅಪ್ಲೈ ಮಾಡಿದೆ, ಸೊ ಏನಾಗುತ್ತೆ, ಸೊ ಇಟ್ ವಿಲ್ ರಿಸಲ್ಟ್ ಇನ್ ನಾನ್ ಯೂನಿಫಾರ್ಮ್ ಅಪ್ಲಿಕೇಶನ್ ಆಫ್ ಲೋಡ್. ಒಂದ್ ಕಡೆ ಲೋಡ್ ಜಾಸ್ತಿ ಹಾಕಿ ಒಂದ್ ಕಡೆ ಕಮ್ಮಿ ಹಾಕಿದ್ರೆ ಏನಾಗುತ್ತೆ, ಸೊ ಎಲ್ಲಿ ಲೋಡ್ ಜಾಸ್ತಿ ಇದೆನೋ ಅಲ್ಲಿ ಜಾಸ್ತಿ ಡೌನ್ ಹೋಗುತ್ತೆ ಅಲ್ವಾ. ಸೊ ಸೇಮ್ ಅಪ್ಲೈಸ್ ಇಯರ್. ಅಗೇನ್ ಎಕ್ಸೆಂಟ್ರಿಕ್ ಲೋಡಿಂಗ್. ಸೊ ಅಂದ್ರೆ ಒಂದ್ ಸೈಡ್ ಲೋಡು ಜಾಸ್ತಿ ಹಾಕೋದು. ಸೊ ವಾಟ್ ಆಲ್ ದ ಪ್ರಿವೆಂಟಿವ್ ಮೆಷರ್ಸ್ ವಿ ಕ್ಯಾನ್ ಟೇಕ್ ಟು ರೆಡ್ಯೂಸ್ ದಿಸ್ ಎಫೆಕ್ಟ್? ಫಸ್ಟ್, ಸೊ ಫಸ್ಟ್ ನಾನು ಏನ್ ಹೇಳ್ದೆ, ಇಟ್ ಶುಡ್ ಬಿ ಆಫ್ ಯೂನಿಫಾರ್ಮ್ ಫೌಂಡೇಶನ್ ಇರಬೇಕು. ಸೊ ಯೂನಿಫಾರ್ಮ್ ಫೌಂಡೇಶನ್ ಇರ್ಬೇಕು ಅಂತಂದ್ರೆ ಐ ಹ್ಯಾವ್ ಟು ಡಿಗ್ ಆರ್ ಡೂ ದಿ ಫೌಂಡೇಶನ್ ಟಿಲ್ ಐ ಗೆಟ್ ದಿ ಆರ್ಡ್ ಸ್ಟ್ರೇಟಾ. ಆರ್ಡ್ ಮೀನ್ಸ್ ಲೈಕ್ ರಾಕ್ ಬರೋ ತರ, ಅಥವಾ ಇಟ್ ಶುಡ್ ಬಿ ವೆರಿ ಹಾರ್ಡ್ ಮೋರಮ್. ಸೊ ಆ ತರ ಬರೋ ತರ ಐ ಹ್ಯಾವ್ ಟು ಡೂ ದಿ ಎಕ್ಸ್ಕವೇಶನ್ ಆರ್ ಫೌಂಡೇಶನ್. ಅಗೇನ್ ಐ ಶುಡ್ ಅವಾಯ್ಡ್ ಎಕ್ಸೆಂಟ್ರಿಕ್ ಲೋಡಿಂಗ್. ಸೊ ಎಕ್ಸೆಂಟ್ರಿಕ್ ಒನ್ ಸೈಡ್ ಲೋಡ್ ಜಾಸ್ತಿ ಹಾಕಿ ಆ ತರ ಮಾಡೋದ್ನೆಲ್ಲ, ಆ ಕಂಡೀಷನ್ಸ್ನೆಲ್ಲ ನಾನು ಅವಾಯ್ಡ್ ಮಾಡ್ಬೇಕು. ಅಗೇನ್ ಐ ಶುಡ್ ಫಾಲೋ ದಿಸ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಡಿಸೈನ್ಸ್ ಆಫ್ ಕನ್ಸ್ಟ್ರಕ್ಷನ್ ಅಂಡ್ ಸ್ಪೆಸಿಫಿಕೇಶನ್ಸ್ ಗಿವೆನ್ ಬೈ ದಿ ಗೌರ್ಮೆಂಟ್. ಸೊ ಅದನ್ನ ನಾನು ಕರೆಕ್ಟ್ ಆಗಿ ಎಲ್ಲ ಚೂಸ್ ಮಾಡ್ಬೇಕಾಗತ್ತೆ. ಸೊ we'll move on to the next slide. So this is the pictorial representation of a unequal settlement of a subsoil. See in this picture, you can see this side, you see this sandy soil. Sandy soil, it has a good bearing capacity. Again, illi silty soil, poor bearing capacity. So poor bearing capacity iro kade enagide building, it started bending. Okay, so because of this unequal settlement of a subsoil, see the soil underneath this house or building, so this is called as a subsoil. Due to difference in soil and different in bearing capacity, it started getting crack, right? It started bending towards the poor bearing capacity of soil. Okay, we'll move on to the next slide. Second one is unequal settlement of the masonry. What is masonry? Masonry means the construction, what we do. Okay, so more for the masonry work, we choose bricks, concrete blocks, etc. Okay, the mortar, what we use for the masonry work should be of good quality, right? The cement, okay, sand, what and all we use, and water. So everything should be of a good quality, so it won't get dry very soon, or it will not do the differential settlement. Okay, so what are the preventive measures can be adopted to control this? So by using good quality of mortar, as I said, good for a proper bond, what we need, proper strength, we need a good quality of mortar. So we can use good aggregates, good sand, fine aggregates, cement, and potable water. If you use properly and do the mortar, so mortar strength will be good. Again, by using mortar, thin mortar joints, the joints between the two bricks are two concrete blocks should be thin, okay, thin enough to maintain the good strength. Third one is, as you all know, per day height of the masonry constructed per day should be 1.5 meter. It shouldn't exceed more than that. Okay, so that should be maintained. Again, the check for the masonry, like whether it's properly rectangular. So by checking all this, taking preventive measures, it can be prevented. Fourth one is, masonry work should be cured properly for 10 days. Means the curing aspect is very important in the construction of masonry. It should be cured for 10 days, minimum of 10 days, to achieve the full strength of a masonry. Okay, so if you construct a wall of 1.5 meters, then it has to be cured for 10 days. Then only further construction of a wall can be carried out. Okay. Next, we'll move on to the next slide. See, this is the pictorial representation of a unequal settlement of a masonry. See, all these cracks has been happened in the building. Third one is horizontal movement in the adjoining soil. So when see, this is the issue with the soil. Okay, so actually this type of common type of a problem is seen in the clayey soil and black cotton soil. Why? Because there is a volumetric change in the soils when it's subjected to moisture. When rainy seasons come, the clayey and black cotton soil will rise up. Means it will become like double the quantity almost. Means it will be popped up. Okay, to some extent due to increase in the moisture content in the soil. So if a building is constructed in this types of soil, what happen? There will be a horizontal movement in the adjoining soil. Okay, so due to volumetric change in the soils. Okay, what kind of a preventive measures can be taken in this case? So in this case, if we are constructing a building on a black cotton soil or clayey soil, the foundation loading intensity in the foundation, the loading intensity should be maintained to 5.5 tons per meter. Okay. Again, in the next point, depth of a foundation should be such that cracks may not reach it. Means depth of the foundation should be increased to a minimum of 0.9 meter, even more than that to achieve the full strength of a foundation. Okay, we'll move on to the next slide. Fourth cause is moisture withdrawal from the subsoil. When the water table falls, the soil particles lose cohesion and there is chances of shrinkage of soil leads to crack in the structure. Okay, what happens in this condition? The moisture will be taken out from the subsoil. Okay, due to plantation, again due to deeper foundations, like that. Okay, what all the precautionary measures can be taken for this? So for this, if trees are there, big trees are there, should be located little far distance, say 1.5 times the height of the mature tree. So like that. So tree should be planted at a safe distance from the foundation. ಸೊ ಇವಾಗ ಒಂದು ಪ್ಲೇಸ್ ಇರತ್ತೆ, ಅಲ್ಲಿ ನೀವು ಮನೆ ಏನಾದ್ರೂ ಕಟ್ಟಿರ್ತೀರಾ, ಅಲ್ಲೇ ಹತ್ರ ಒಂದು ದೊಡ್ಡದ್ ಮರ ಇರುತ್ತೆ. ಸೊ ವೆರಿ ಕ್ಲೋಸ್ ಆಗಿ ಇರಬಾರ್ದು. ಅವಾಗ ಏನಾಗುತ್ತೆ, ರೂಟ್ಸ್ ಫ್ರಮ್ ದ ಟ್ರೀ ವಿಲ್ ಗ್ರಾಬ್ ಮಾಯಿಶ್ಚರ್. ಸೊ ಟ್ರೀಸ್ ಏನ್ ಬೇಕು, ವಾಟರ್ ಬೇಕು. ಸೊ ವಾಟ್ ವಿಲ್ ಡೂ, ರೂಟ್ಸ್ ಇಂದ ಏನ್ ಮಾಡುತ್ತೆ, ಮಾಯಿಶ್ಚರ್ ನ ಗ್ರಾಬ್ ಮಾಡ್ಕೊಂಡ್ಬಿಡುತ್ತೆ. ಸೊ ಅದಕ್ಕೋಸ್ಕರ ಯಾವ್ದಾದ್ರು ದೊಡ್ಡ ಟ್ರೀ ಇತ್ತು ಅಂತಂದ್ರೆ ಅದು ಬಿಲ್ಡಿಂಗ್ ಹತ್ರನೇ ಇರಬಾರ್ದು. ಸೊ ಒಂದ್ ಸ್ವಲ್ಪ ಸೇಫ್ ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ, ಸೇ ಯೂಶಲಿ ಆ ಡಿಸ್ಟೆನ್ಸ್ ಎಷ್ಟಾಗಿರ್ಬೋದು, 1.5 ಟೈಮ್ಸ್ ದಿ ಹೈಟ್ ಆಫ್ ದಿ ಮೆಚರ್ಡ್ ಟ್ರೀ. ಓಕೆ, ಸೊ ಅಷ್ಟಿದ್ರೆ ಸೊ ವಿ ಕ್ಯಾನ್ ಗಿವ್ good foundation. Next one is precaution measure is foundation should be carried deeper. Okay, ಸೊ ಏನಾಗ್ಬೇಕು, ನಾನು ಆ ಟೈಮಲ್ಲಿ ಏನಾಗ್ಬೇಕು, ಟ್ರೀ ರೂಟ್ಸ್ ಎಲ್ಲಿ ಇರುತ್ತೋ ಅದಕ್ಕಿಂತ ಸ್ವಲ್ಪ ಕೆಳಗಡೆ ಹೋಗೋ ತರ ನಾನು ಫೌಂಡೇಶನ್ ನ ನೋಡ್ಕೋಬೇಕು. ಫೌಂಡೇಶನ್ ಶುಡ್ ಬಿ ಕ್ಯಾರಿ ಡೀಪರ್ ಅಂಡ್ ನೋ ಪ್ಲೇಸ್ the depth of foundation should be less than 0.9 meter. ಸೊ ನಾನು ಯೂಶಲಿ ಲಾಸ್ಟ್ ಸ್ಲೈಡ್ ಅಲ್ಲಿ ಹೇಳ್ದಂಗೆ 0.9 ಮೀಟರ್ ಗಿಂತ ಡೆಪ್ತ್ ಕಡಿಮೆ ಇರಬಾರ್ದು. ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಇನ್ಕ್ರೀಸ್ಡ್ ಬಟ್ ನಾಟ್ ಲೆಸ್ ದೆನ್ 0.9 meters. Okay, we'll move on to the next slide. Fifth one, the lateral pressure on the superstructure. So what is lateral pressure? First of all, the pressure which acts on the horizontal to a right angle direction. So right angle direction ಆಗಿ horizontal way ಆಗಿ ಇದು act ಆಗುತ್ತೆ. Usually where it exists, so it will come into criteria when you will design for a retaining wall. Okay, so retaining wall ಗೆ matter ಆಗುತ್ತೆ. So it acts, the pressure, lateral pressure, how it acts horizontally. So horizontally act ಆಗೋದ್ರಿಂದ what ಆಗುತ್ತೆ, because of that the building will start tilting. So overturn ಆಗುತ್ತೆ. So to control this, precautionary measures we have to take. What kind of a precautionary measures can be taken for this? For this, wide base means width of the foundation should be increased. By this, the overturning will be reduced, because if you give more width, height will be less, so it will withstand, right? So that way, so width of the foundation should be increased to resist lateral pressure on the superstructure. Okay, we'll move on to the next slide. Last one, the action of atmospheric agencies, the causes, what it, why it happens. Atmospheric agencies means what? Due to heavy rain, wind, moisture content. Okay, so water will get collected near the foundation. Again, what it will do infiltration. So means penetrating inside the building. So because of that, so while it carrying the water, it will carry salt, sewage, animal dung, all other waste, plant waste, everything will be carried, and it has some salts also in it. So what happens when all this things come contact with the foundation concrete? It will start reacting chemically, right? Because of that, the foundation material may go disintegration. Means it will lose its strength. So because of that, there will be foundation failure. What all the precautionary measures can be taken for this is, depth of the foundation should be sufficiently deep and shouldn't allow any rainwaters, or it should be minimized. Again, a check for the water table has to be done before constructing. Again, a proper water table drainage should be provided before constructing a foundation. So these are the precautionary measures to take should be taken for action of atmospheric agencies. Okay, I'll show a picture showing different types of failures of foundation. See, this is unequal settlement. So this is tilting, and this is due to atmospheric agencies. So there are cracks has been developed, and this is due to different types of soil and unequal settlements, and cracks has been developed in the building. Okay, we'll move on to the next slide. So unequal settlement of subsoil. So what's happening here? See, trees root drawn moisture from the ground, causing the settlement. See, so tree roots are taking water from this subsoil. Because of that, so it's drawing the moisture from it. Again, the plumbing leakage. Okay, plumbing leakages. So here what's happening? The service connected to this building, like water supply, sewage, etc. There will be leakage from that, and it will have some salts, other components. It will start reacting with the foundation base. Then it will lose its strength. Next is expansive soil, means volumetric change in the soil, means it doubles in the size or increase its volume to some extent. Next, construction over a uncompacted or filled dirt. So I said before construction, compaction is a must factor. It has to be compacted very well. Then only construction will be strong. Our building will be strong. Then compressive soil. So the soil is getting compressed too much. Because of that also there will be an unequal settlement. Okay, I would like to share a small video regarding this. Just watch us. This. Okay. Just watch this video.
The first question many homeowners may ask themselves is, why is this happening in my home? Many factors contribute to structural settlement. The most common cause of foundation settlement is inferior support soils. Homes built on soft, low-density soils or fill that have been improperly compacted is a leading cause of foundation problems. In many cases, problems may not present themselves for many years after the original construction due to the slow progression of differential settlement. Environmental factors are another common cause of soil instability. Evaporation of the moisture in the soil beneath your structure can lead to soil contraction. Extreme summer heat and drought can cause soils to dry out and shrink, causing the foundation to settle. Moisture in the soil can be depleted due to nearby trees and shrubs. If the soil supporting your home contains expansive clay, shrinkage and swelling of the soil can also result in more movement beneath your home, causing even greater potential damage. Improper drainage can also lead to foundation damage. Excess moisture can erode or consolidate soils, causing a structure's foundation to begin to settle. Many poor drainage issues are due to improper guttering, plumbing leaks, and the slope or grade of the land. Should the support soils contain expansive clays, excess moisture resulting from improper drainage can cause the soils to swell and heave up, lifting the foundation. This can result in serious damages and extensive, costly repairs. The causes of foundation failure on one's home or business can be varied and unique to each structure and location. The signs of structural movement are essential to resolving the causes of foundation movement. Understanding these causes is key to finding a lasting resolution against further movement.
Okay, even seen the video. So there he was explaining what all the causes for unequal settlement of structure, and he was showing even the plumb level and checking verticality and spirit level to check whether it's horizontal ground is not, and other different factors he was explaining. I think hope everyone understood why settlement happens and what are the preventive measures can be taken before construction to avoid unequal settlements. Okay, and we'll move on to the next slide. So that is, you'll be having small test, assessment level test, how much you understood about this topic. Let's answer the questions. Question. The first question is a statement. You have to decide whether it's true or false. Question number one. The main cause of failure of foundation is due to unequal settlement of subsoil. True or false? Okay. The statement is true because if the soil is good, then we can achieve good foundation. Question number two. Withdrawal of moisture from subsoil. Option A, trees should be planted at a safe distance from the foundation. Option B, by pile foundation. Option C, by combined footing. Option D, by proper masonry work. Okay. Answer for this question is option A. Trees should be planted at a safe distance from the foundation. Right? Otherwise, what will happen? Roots of a trees will absorb the moisture from the subsoil. Question number 3. The property of a soil which permits water to percolate through it. It is called as option A, moisture content, option B, permeability, option C, capillarity, option D, none of this. Okay, the answer is option B, that is permeability. Means if water is percolating, means going inside the soil, means its permeability. We'll move on to the next slide. Question number 4. The pressure intensity beneath the footing depends upon option A, rigidity of footing, option B, soil type, option C, condition of soil, option D, all the mentioned above. Okay, the answer is all of the mentioned above. Means pressure intensity depends on all the factor: rigidity, soil type, condition of the soil. Right? Then question number 5. When two columns loads are equal, which of the possible footing can be provided? Option A, strap footing. Option B, raft footing. Option C, trapezoidal combined footing. Option D, mat footing. Okay. The answer is option C, trapezoidal combined footing. Right? So it will give more strength to the foundation. Okay. By this question, your assessment level is done. Hope everyone has done well. We'll move on to the next slide. Okay. For this video, I think we have understood about the settlement and its precautions taken for the foundation level. Okay. And thank you. I will thank our team for this presentation. And we thank our reference members to provide the information regarding this topic. Thank you, one and all.